Let us try another examples on the integrating factors. You are given the differential equation here. It is given that the solutions for the equation is this, and the boundary conditions are x equals to 1 when y is equals to 1. To solve these questions, first write down the functions here. Rearrange it in this format where you can identify the p and the q. This is done by moving this to one side while the constant to the other side. You need y on this side. After rearranging, you get this. Compare the structure here with this. You know that 1 per x is actually p and negative 1 will be the q. This gives you p and q. Now you have to integrate p here. Integrating p will give you ln x. Adopt the ln x into the integrating factors, which is e ln x, and this will give you x ultimately. Your next step will be substituting the integrating factors by using the formula here. You know that this e power of the integration p dx, it will be equals to the x. With that will give you yx equals to negative x dx. The negative 1 here is due to the q, based on the formula here. From here, you just need to integrate the x. After integrations, you get these functions, and it is given that x is equals to 1 when y is equals to 1. Substitute the relevant value into the function here, you get your c equals to 3 per 2. Now you substitute the c into the function here, you will get this. Rearrange the equations and you will get your final solution here. And this final solution is the same as given in the question here, and the question is solved. Let us try another example on this. We are asked to determine the solutions for the function here, given that x is equals to 0 and y is equals to 2. Write down the function here. Rearrange it in the format of dy dx plus py equals to q. This is done by moving the negative x to the opposite side, which will give you this. Compare the function here with the structure here. You know that p will be equals to 1 and q will be equals to x. This gives you p equals to 1, q equals to x here. Now you need to integrate p over dx. P is equals to 1. Substitute into the function here. You are integrating 1 over dx. After integrations, you obtain x. Now for your integrating factor here, you know that this one is equals to x. Your integrating factor, it will be e power of x as obtained from here. Substitute the integrating factor into the function here. This is the formulas for the integrating factors. This will be substituted here and here, and there will be a q. The q is obtained from the calculation step here. And now you need to integrate this. The relationship is in the mode of product. Therefore, you need to integrate this by parts. Let u equals to x, while the rest equals to dv. Differentiate u, you get dx. Integrate dv, you get v. Use the formulas of integrating by parts. U, V, V, dx. Integrating this, you obtain this. Based on the calculation step here, you know that integrating this, you will get these functions. Substitute this into the function here, you get this. Given that x is equal to 0 when y is equal to 2, substitute the relevant value into the function here, and you are able to obtain c. You know that e power of 0 will be equals to 1, and all the e powers to 0 will be equals to 1. Solve the function here, you get c is equals to 3. Substitute the c into the function here, then you will obtain this. Move the e power of x to the opposite side. This will cancel out the e here, and there will be an e of power of negative x. This will be your final solutions for the problem.